Hello students, today I am going to give a demonstration on function generator. So after this video you will come to know the maximum points. Otherwise I will cover maximum things about the function generator, what is function generator, how to make use of this function generator. This is equipment usually we come across in engineering colleges and in giving certain inputs to the electronic circuits. So I will explain about give a demonstration about this function generator. So first thing is you'll see through the technical specifications. So what I am here having the function generator of the make that is a JS instrument make function generator. The model is 806 and the same make the model is 8010 JS 8010. So only thing the difference is it is the advanced one compared to this one. So here coming to this function generator, so input for this function generator is 230 volts AC. It works on 230 volts AC. So this is a power on button. So after switching the power on, you will have display here, LED display or LCD display, and these are the push buttons. In this block they have given the push buttons for frequency 20 to 2 mega. That means frequency selection will be 20 hertz to 2 megahertz. You can select the ranges. And the meanwhile, and this block is for different functions of waveforms. This is a sine function, square, triangle, and the pulse. And this is one important block. This is called attenuator block. 20 decibels and 40 decibels. So first I will go one by one, and it is about the amplitude knob. This is the knob we are using to vary the amplitude, adjust the amplitude, and it is a width knob. This will helpful when you are selecting the pulse. So this is offset. It is having certain applications. Offset off and offset on, and it is a control button for positive offset and the negative offset. And this is the circuit for given FM in. This is the rare application what you are using in the laboratory. The main thing is we are taking the output from the here function generator. So since it is a source device, it is giving certain voltages and frequency. Usually we say that audio frequency oscillator also, that's another name for function generator. So in this thing audio frequency oscillator, that means audio frequency is 20 hertz to 20 kilohertz. But now the function generator, it has come because the maximum frequency available is 2 mega and 10 mega also it is available. So this is the variable knob to adjust the frequency. So first I will go one by one. So this is the technical specification. You just go through this technical specification. So in this, the first block is waveforms, sine, square, triangle and pulse. 2 hertz to 2 mega, so I have taken 2 hertz to 2 mega. So and the selection push button it is there, and the frequency readout by the display LED, or in this case it is a LCD display. So output, the maximum voltage what we are getting out of this function generator, it is 20 volts peak to peak. And these are the specifications. Attenuation levels are 20 dB and 40 dB. I will tell you what is the use of that attenuation later. In general, the power requirement for this function generator, it would be 230 volts AC, 50 hertz and 5 amps. This is the main outlet socket I have connected, and this is the power on button. And coming to this, actually this thing, so how you will take the signal and adjust to our circuits. The main function of function generator, it will produce different functions of waveforms at different frequency and different amplitude you can adjust. So suppose for our circuits, suppose for our amplifier circuits, we require the input voltages that will be in millivolts, because amplifier circuit does the amplification. That means it raises the weak signal, strength of the weak signal. Input for that will be in terms of millivolts, suppose 10 milli, 50 millivolts. So output, it is expected output, it is in terms of voltage. Say suppose 50 millivolts input you apply to the amplifier circuit, the expected output would be 5 volts, depends on the gain factor what you have designed the amplifier. So that means for amplifier circuit input will be, you should apply the 50 millivolts. Suppose in another example, if you take, suppose say example attenuator circuits, what happens? Attenuator is a circuit which reduces the signal level, or else we can say that introduces certain amount of loss to the signal. In that, input voltage will be very high. Very high means in terms of 5 volts, 10 volts. The output expected voltage in terms of millivolts as per your decibels what you have designed. In that case, you require the voltages levels will be 5 volts, 10 volts. Whereas in case of amplifier, I told earlier, it will be in terms of millivolts. So in this case, there is a confusion how to adjust the voltages and how to make the adjustment with the function generator. Every student is having doubt in that manner, because the range is 0 to 20 volts peak to peak they have given, but what they had given is two attenuation buttons, 20 dB and 40 dB. So when to use 20 dB and when to use 40 dB? So what is the position of attenuation levels, how to select the frequency, how to adjust the amplitude, these are the things one must know. So first thing is, I will show the first how to this thing, switch on the initial thing, switch on the function generator. Next I have taken one BNC probe, BNC to BNC, and for measuring and adjusting the voltage I have taken CR, cathode ray oscilloscope, analog CR. So first thing is, I will connect probe, N10 probe I have taken to the CRO. So first I will show you with respect to our chart. I have made one chart for you. See here, output voltage available from function generator is 20 volts peak to peak. That means, observe here, this is a very important point, 20 dB and 40 dB, if both the push buttons are in release condition, then if you fully clockwise, you keep this knob, the amplitude now fully clockwise, and release this position, the maximum voltage what you are getting out of this function generator would be 20 volts peak to peak. Condition is, it should be in both release condition. That is what I have given here. If both in release condition, fully maximum amplitude, so maximum amplitude, the voltage will be 20 volts. So what happens when I press this 20 dB? The same range reduces to 2 volts peak to peak with the maximum amplitude level, this knob. If you press along the 40 dB, the range is reduced to 0.2 volts peak to peak, or else we can say 200 millivolts with the maximum amplitude. If you press both the attenuation levels, what happens? The total attenuation will be 20 plus 40, 60 dB attenuation. If you go through with the maximum amplitude, the range is reduced to 20 millivolts. This is the chart. You just go through this. Then given examples also. If you want, when 5 volts is required, what should be the attenuation levels, and 1.5 volts, what is attenuation level, 40 dB. If you want 10 millivolts, I will show you the practical things. Practically I will do it and show you. When to have 20 dB and 40 dB and when to release this. So first thing is, this is the frequency readout, display, LED display, and these are the selection. First I will keep the frequency 1 kHz by adjusting here 1 kHz frequency, and I have taken sine wave, and I am keeping both in release condition. I will show you the maximum voltage. I have keep this fully clockwise release condition. The voltage will be 20 volts peak to peak. See here, on the CRO it is at 20, and the signal what you are getting is sine wave, that is covered one division vertically. As you measure the voltage across vertical axis, so one division 20, so 1 into 20 is 20 volts, that is we are getting. So if you again press the 20 dB attenuation, the same range is reduced to 0.2 volts. Here 0.2 volts, 2 volts it is there, one division. Suppose if I press 40 dB, as I told, the range becomes 20 dB, the range will be 2 volts. See here, 2 volts it is there for 20 dB. 40 dB, if I press by releasing this 20 dB, the range reduces to 0.2 volts. So if I press both attenuation levels, what would be the range is 20 millivolts. See here, 20 milli it is there, and the voltage, if you see across the scope, that is one division it has covered, it has a 20, that means what you are getting is 20 millivolts. Both the release condition 20 volts peak to peak, 20 dB alone press 2 volts, 40 dB alone press 0.2 volts, and 20 plus 40, the range is 20 millivolts. It is a chart, it is given. Now the question is, when should you have the attenuations on the particular example? So I will show you. Suppose if someone asks you to adjust the 5 volts, what I will do is I will release both the conditions. I know the range is 20 volts maximum, and I will keep here at the 5 position, and the signal it is there. Now I will adjust the amplitude here. Observe here. Reduce the amplitude so that it will cover one division. Now the signal is okay. Suppose if someone asks you to adjust the 4 volts, what you can do is I will shift it to 2 volts position, volts per division now. Now I will adjust the voltage level in vertical positions to cover it to 2 divisions. Here adjust the amplitude, I am adjusting parallelly the amplitude. See, it is the amplitude knob. I am adjusting the amplitude 2 divisions. I will see that it is covered. So 2 into 2 it becomes 4 volts. I have adjusted. So this is how you have to adjust. It is in terms of volts, since these two are release conditions. Suppose if someone asks you to adjust 0.5 volts. So 0.5 volts, you know that it lies in the range of 20 dB. I will press 20 dB and keep this knob to 0.5 volts and see that it should cover the maximum one division. 0.5 is there. Suppose if you can keep for better accuracy 0.1 and adjust the amplitude also, it should cover 5 divisions. 0.1 into 5, that is also 0.5. 1, 2, 3, 4, 5 divisions. See here, adjust the amplitude. Suppose amplitude, if it is like that, you reduce and adjust the amplitude so that the signal covers 1, 2, 3, 4, 5 divisions. 0.1 it is there. Again, if you come to 0.5, nothing but it is one division. If you keep the volts per division 0.5, it covers one division. 0.1, it covers 5 divisions. It is one and the same. It is only a multiplier. So actually the amplitude adjustment you see here, I have to vary with the help of this amplitude knob. This is actually the main thing. So here it is only output device, you can observe the signals. So suppose if somebody asks you, as I told for the amplifier example, 20 millivolts, I have to go for both the attenuation levels and maximum amplitude. See here, 20 milli it is there, 20 milli, 20 milli, it is 20 milli. Suppose if someone asks you to adjust 20 milli, it is the amplitude knob. Now suppose someone asks you to adjust the 10 milli. 10 milli means, no, it is a 20 milli. Now I will adjust the amplitude knob. So signal cover vertically one division. Adjust the knob. So signal is like that. Adjust the knob and it covers, see here, one division. One division, so that the amplitude will be 10 millivolts. 10 millivolts. Suppose if someone asks you to adjust 100 millivolts, as I told, 40 dB it is nothing but 0.2 volts range or 200 millivolts. The maximum will be 200 millivolts. What I will do is I will give it to 50 milli, in the pulse position of 50 milli, and the signal, no, it is covered around more than 4, nearer to 4. I will cover 2 divisions vertically, so that 2 into 50 is 100 milli you are getting. The attenuation position will be 40 dB. This is about the 20 dB and 40 dB attenuation. If you have doubt, you can go through the chart and you can make yourself, then it will be perfect. And about these other knobs, frequency adjustment is very simple, not much tough as amplitude adjustment. It is very easy. Just press the push button by observing the range. Suppose you want 100 Hertz, go to the 200 and adjust these knobs. Maximum will be 200 and half of that will be 100. or if you want to 50 Hz, you can change these knobs. Suppose if you want to kilohertz, go for the 2 kilohertz range. 500 Hz, if you want to adjust in that range, you can have 500 Hz. Now it is 0.4 K means 0.59 K means it is a 590 Hz. 20 K, 200 K and 2 mega like goes on. And to change the functions, here to change the functions, it is a sine function, observe here, and it is a square function, and it is a triangle function, and it is a pulse. Whenever you are having the pressing the pulse, you can adjust the width here. See here, the width is varying. Here the on period is more, off period is less. You can adjust the width when you press the pulse. When you press the square wave, this if you press square and go for adjusting the width, it is not possible, because square wave it is having 50% duty cycle. You know that only the pulse we can change the duty cycles, that is on and off period. Pulse it is I am changing the duty cycle. It is a sine, square, triangle and the pulse. And what about this offset? I will give you the example of sine or square wave. See here, when you keep the square wave, suppose if you want to have some DC shift for the circuits like digital checking circuits, you go on pressing the amplitude, the offset down button, you press for this thing DC and you level, you release this and you off this, the signal is both the positive and negative cycle, half of that, from 0 to positive side and 0 to negative side. From if you go on switching on the offset, what happens? The signal you can manually shift from 0 to certain positive level and from 0 to certain negative level. See here, signal is moving on. Signal is moving on. And if you go for negative, the signal is moving down. So this is a diagram I have written. So it is very clear picture you can understand. This is a signal having no offset, 0, positive voltage 1 volts and minus 1 volts. So it is a with positive offset, from 0 you can get 2 volts here. You can adjust with the knob, offset knob. Here it is a 0 baseline. Negative side if you go, that is called with negative offset. No offset, baseline 0, positive side and negative side. 0 positive offset, it is a positive side, it is shifting, that is a DC shift we call. 0 negative side with negative offset. So you go through this waveform, you will easily understand what is this offset and all. These are rare application we are using for normal circuits. In certain triple applications and TTL signal applications, you will come across this. So this is about the function generator. I think I covered maximum points. And one more thing is, this is another make. The same thing, function generator, this is another make. See here. Here range I have given these micro switches. See here. Here also same attenuation buttons are there, 20 dB, 40 dB. For waveform in this function generator you can select here. Waveform button they have given, waveform, sine, square angle and pulse. Pulse also there is a common thing, pulse width you can change here. Here waveform you can sine, triangle, pulse. Only one button I have given. In this case they have given 4 push buttons. Here on macro switch, what you call this switch is called, they have provided. And this is frequency they have given. Here the range, 2 ranges they have given. This is the lower range and it is higher range. This is the frequency variable knob. This is a pulse width. Only when you select the waveform pulse, same pulse width come as I told in another FG, previous FG. It is offset. Always it should be in lock position and it should be in the off position. In your electronic applications, if you are not using this, you make it off. This is very important point. Offset it should be in off position. And it is an amplitude knob as I told, 20 dB, 40 dB. The same function generator, some advanced features it is having, LCD display. So this is about the function generator. I think I have covered all the points. These are the charts I have made. This is for voltage level adjustments, technical specification, and it is a waveform. Okay, I think I covered all the points. Thank you very much.